Section 5 of Chapter 6 is simply titled Strategies for Factoring. So what we're going to do is just practice all that we've been doing in the last few sections, all right? So there's going to be a lot of talking before we do several examples. So what I want you to do is this. Get your notes out. Please, please, please get your notes out and follow along. Write this down. Here we go. So the first thing, when you're factoring, here's the steps, all right? Some of you like step by step by step. What do I do? Where do I start? Here it is. So step 1, factor out the GCF. Okay, I'm going to go ahead and read through. If I'm going too fast, go ahead and pause and write it out. I'll make sure you understand where each part is coming from. So first you're going to factor out a GCF. All right, is there anything in the whole polynomial that is the same in each of those terms that can come out? So first get that out and then find out what's left in all of the other parts, in all the other terms of the polynomial. That's step 1. All right. Step 2 is all of this together. So step 2, what you're going to look at is, okay, what's left in those parentheses? The first thing to look for is how many terms are left. Are there 4 terms? If there are 4 terms left that you need to factor, you're going to see, can we use grouping? All right, so if there's 4 terms, your strategy is to use grouping to factor those. All right, if there's 3 terms, and most of the time in the problems that I'm giving you, there will be 3 terms. If there's 3 terms, you're going to use backwards FOIL, just like we did, to determine, and sometimes you might have to use guess and check to figure out what are the binomials that you multiplied together to get this trinomial. With that, you can watch for those perfect squares. If you can recognize that pattern of a squared plus 2ab plus b squared, if you can recognize that pattern, then you can quickly pull out a perfect square, a binomial that's squared. All right? If you can't, that's fine. Just use backwards FOIL. All right? Very few of those, some of those in the, I think one of those in the problems that I give you, once you factor out the GCF, that trinomial won't factor any further. And if so, you're done. All right. But most of those will factor down to binomials. All right. If there's not 3 terms, if there's only 2 terms, you're going to look to see, is that a difference of 2 squares? If it is, then that's an a plus b, a minus b format. All right. And there again, if you're not for sure about how does that work, you can still use the backwards FOIL, even if it's just this, the x squared minus a perfect square. All right. Once you get to that step, once you've factored that first time, then you check your results for more factoring. Always, always, always check your answer to find out, is this as far as it will go? Or can I go one step further? Okay, let's do some. Here we go. Ready or not? Here we go. All right, 6r squared minus 15r cubed. Step 1 is to see, is there a GCF? I can look at my constants. 6 I know is 2 times 3, and 15 is 3 times 5. And so they do have the 3 in common. So I can pull out a 3. And we've got r squared and r to the 3rd. So there's 2 r's in both of those. So I can pull out an r squared. So then I have to see, well, what's left inside? What did I not take out? So 3 times what was 6? 3 times 2 is 6. And then r squared, I took all of the r out. So all I have left is 2. Minus 3 times what was 15? Well, 3 times 5. So I have 5 left here. And I have one of these r's didn't get taken out. So 5r. Okay, so that's taking out the GCF. 3r squared times the quantity 2 minus 5r. Then I look to see it's a 2. There's two terms. Is this a difference of 2 squares? No, it's not. This is not factorable. We're done. So this is your final answer right here. All right, let's do another one. If you think you've got it, pause and do it, and then come back and see if you got it, okay? This should all be stuff that you know how to do. I'm just putting all of the different types together in one lesson, all right? Here we go. First, we're looking for a GCF. There's not a B in this one, so I can't use B's, but all of these numbers are even, so I can pull a 2 out of each of these. So if I pull a 2 out of here, B squared is left. 2 times 7 is 14, and I still have the B. And 2 times 12 is 24. All right, so now I look to see, well, I have 3 terms, so I'm going to use backwards FOIL. And I can quickly look and see b squared is a perfect square, but 12 is not a perfect square, so it's not going to be a perfect square trinomial. So I can just do FOIL and see if it'll go further from here. So I look to see, oh, don't lose the 2. B times b is b squared. 12, okay, so now we have to find our pieces. 1 times 12 is an option, and 2 times 6 is an option, and 3 times 4 is an option. So I know that the signs are the same, and I know that the signs have to be positive. So both signs are positive. And if both signs are positive, I'm going to add together. I'm going to add these 2 numbers to get 7. Oh, so that's 3 and 4. 3 plus 4 is 7. So b plus 3 and b plus 4. And both of these are as far as they'll go. They're not a difference of 2 squares because there's not a difference involved. So 2 times b plus 3 times b plus 4 is your final answer here. Okay, let's do another one. Pause and do it yourself and then come back, okay? You can do this. All right, did you do it? I hope so. Okay, here we go. So 4, 12, and 4, let's take out a 4. And what we have left is h squared plus 4 times 3h plus 1. And if I try to use, so now I've got a trinomial, so I need to try to use FOIL. So keep your 4. And I've got h and h. Oh, and 1 is easy. That's just 1 times 1. It has to be. Oh, but looky there. 1h plus 1h is 2h, not 3h. And there is no other combination. So we simply say, whoops, this step is not an option. And so this is my final factored product. All right? And that's how you know. You just keep going until, whoa, something's not right. It didn't work. And then you know. All right, 5p squared minus 80. Look for the greatest common factor. 5 is in common. So 5 times the quantity p squared minus, and if you take 80 divided by 5, you get 16. And p squared minus 16, ooh, that's a perfect square minus a perfect square because p times p is p squared, and 4 times 4 is 16. So I don't even have to use FOIL. I can just know p plus 4, p minus 4. If you didn't just know that, it's okay. FOIL it and say 4 times 4 is 16. 1 is positive and 1 is negative. And yes, negative 4 and positive 4 drop out. And so this is your final answer. This is an easy lesson. It's the same thing you've been doing. And it's a day to practice everything you've been learning. I have one more that's just a little bit trickier, but not a whole lot. Because if you'll notice, we didn't do any that had 4 terms. So let's do one more problem with 4 terms. This one is x to the 5th minus x cubed minus 8x squared plus 8. All right, and if I look at that one and decide, can I factor anything out? There's x's, no. There's nothing in common with all 4. It has to be in common with all 4. All right, so because it has 4 terms, I'm going to use grouping and see if we can get it factored a little bit further. So let's just group these 2 together and these 2 together. And I can look with these. X cubed is in common. I have 3 of them here and 5 here. I can't take all 5 out because there's not 5 of them in this one. So x cubed, and what's left here is x squared minus a whole x cubed here and x cubed here. So I have to put that 1 in there. Remember to hold that place because x cubed times 1 gives me the x cubed. All right? Then we're going to say that minus, there's an 8 in common here, so minus 8. And we have x squared here. And because this is negative, this has to be the opposite of what it is, so minus 1. Negative 8 times a negative 1 gives us the positive 8. That's how we can check it. Okay? Now we can look to see, oh, this did work because the whole point of grouping is to see, do I have a common term that are a common binomial that I multiplied inside there? And I did. This x squared minus 1 was multiplied by both of these 2 things. So instead of spreading it out like that, let's pull that x squared minus 1 out. And let's say, well, I'm going to pull that out and I multiplied it by x cubed and a negative 8, x cubed minus 8. Then we go down and we say, ooh, check the results for more factoring. Guess what? X squared is a perfect square and 1 is a perfect square. So this is x plus 1, x minus 1, and we're going to leave this x cubed minus 8. This is actually a perfect cube minus a perfect cube, and we'll talk about those a different time. Here we go. So this is just x squared, or x plus 1, x minus 1, and an x cubed minus a cubed term minus a cubed term doesn't work the same as a squared term minus a squared term. So we're finished here. X plus 1, x minus 1 times x cubed minus 8. All right. Go for it. You can do this. All right. Lots of the same type of thing. Just make sure that you're checking now and mixing them all up. Okay. So everything that you've learned in the last few sections, you're going to have all together. You can do this. See you soon.